Hello, participants. So far, so good. Now we want to proceed to forecasting time series. And we shall be introducing forecasting by considering uh, time series regression based forecast. So, regression based time series forecast. So, the basic concept here is that we forecast the time series of interest, let's say Y. The assumption that it has a linear relationship with other time series. The time series, which is represented by X here, could actually be trends, season, could be public holidays, and could be any form of intervention variable. For instance, you may wish to forecast daily COVID cases using stringent index, which is the intervention variable in this case, as a predictor. Or we might want to forecast monthly electricity demand using temperature. But in the simplest case, the regression model allows for linear relation between the forecast variable and a single predictor. And that is a typical case of simple regression. So our alpha 0 here is the intercept. Then we have the alpha 1 as the slope, which represents the average predicted change in y, resulting from just a unit increase in x. There are some technical issues that we have to take into consideration. And as we proceed, uh, we see how to manage the situation. One is time lags. Um, in a situation whereby we want to consider the relationship between a variable and its lags, that is, we want to predict a variable using the lags. So how many lags are we going to consider? One lag, two lags. Then another technical issue has to do with correlation over time, the typical case of autocorrelation. Then which method are we going to use? Are we using autoregressive model? Later we are going to learn several other ones, including moving average, autoregressive moving average, autoregressive integrated moving average, and so on. Are we using autoregressive distributed lag? And please let us take notes. We are not, we should not have a causal interpretation of the model. Our concern is that we look at the independent as predictors. Another technical use has to do with conditions under which the dynamic effect can be estimated. And how do we estimate them? How do we calculate the standard errors, particularly when the errors are serially credited? Or, as a reminder, this is basically uh, the way to calculate the autocorrelation. So, just by ways of reminder. And that takes us to autoregression, which is the natural starting point for forecasting model. So we forecast based on the past values of the variable. So an autoregression is a regression model in which, let's say, a variable is y, it is regress against its own lagged values. The number of lags used as regression is called the order. So when we say first order, then we are using just one lag. If you say pth order, then we are using p lag. This is a typical case of first order autoregressive model whereby we are using one lag to predict the variable. And this first order autoregressive can actually be estimated with the use of ordinary list least square regression, particularly if we have discovered our y to be stationary. Yeah, to implement this in R is very straightforward. So we have the function is AR, that AR is in start package, which is part of the system packages. So this our don't forget our TX under TS, that is the maximum temperature. Then the order dot max, that's maximum order allowed. Since we are dealing with first order, it's going to be 1. And we are using OLS as the method. So you have done that, you can just make your forecast. Here we are trying to forecast the model for the next 40 months. And we can plot it. So here where we have this blue is showing us the predicted values. We can divide our forecasting approach into ex ante and ex post. Ex ante forecasts are those that are made using only the information that is available in advance. While ex post are those that are made using later information of the predictors. So for ex ante, we cannot use actual future values of the predictor because they are not actually available anyway. However, the special predictors are all known in advance. For instance, we know in advance the season, we know in advance the public holidays, we know in advance the time, which is the time trend. So this is a typical ex ante forecast where we are forecasting our variable using trend and season. Yeah, we all know this in advance. So if you have done that, then you can make your forecast. Let's say forecast for the next 40 months, and you plot it. We may at times we may want to use some intervention variable. Uh, the simplest case is when we are not considering the lags of those variables. Take for instance, we want to look at the total number of COVID-19 cases and stringency index and people vaccinated. So we select it. That is this what I generate the variable. I call it COVID reg. Then this is exporting it to Excel. This is drawing the graph. So this is the scatter plot here, and this is and this is very very interesting because this is showing you that the total number of COVID-19 cases actually decline with stringency index. So, which means the more you use all these nose marks, social distancing, all sort of things, um, the less the number of COVID-19 cases. It's very interesting. Yeah, the intervention variable, distribute or lag may be included so that you are not just dealing with a simple regression case. So you are looking at a kind of multiple regression model. So some of the predictor we can use include the trend, the season, public holiday, intervention variable, distributed lags, and so on. So and we interpret the coefficient as a marginal effect as usual. But in situation whereby you are using multiple regression, it could be good for you to look at the correlation matrix. And if you want to do that, we use ggRLE here. Then ggps is the function for us to generate the correlation matrix. Then we have what is called scenario forecasting. Scenario forecasting is a situation whereby we have some scenarios for the predictor of interest. Take, for instance, let's say we want to use stringency index as our predictor, or where we may want to look at uh, what will happen if the stringency index increased by 10% for the next 14 weeks. So here we have our age to be 14. Then um, then we need to generate the new data, which we cover the 14 weeks actually. So since we are dealing with weekly, then we have to define our um, COVID data in terms of weekly frequency. So that's why we say frequency equals to 7 years. So we define that for CGS index, we define it for our time series. Um, then we run the regression. So after running the regression, then we forecast this, but we are not using the new data to make our forecast. It's very pretty straightforward. And if you have done this, you get something like this. Now, in case of Scatterplot matrix, so this is what we try to do. Let's say we are not considering more than suggesting this. Let's say we are adding people vaccinated and the dates. It's a kind of fitting where. So we take it from here. So next time we are going to look at various other methods. We start with something simple. We have a mean forecast. We have knife. Then we have so many other methods. Exponential. Um, we have exponential smoothing out approach. So many of them. Hot method, hot linear method. There are quite a lot. Then Arima. So we are going to look at what those methods actually means. And not only that, we'll be looking at how to select the best um, so that we use some level of accuracy to determine which one to actually embark upon to make a final forecast. So that's what we shall be doing later. So thank you. The next thing I will show us how to actually implement this regression based forecast in a very simple way in RStudio.